Is that the whole thing?
I'm not sure.
I'm a little disappointed.
What are we doing on sure now? Reviewing?
Because you can have either one.
Yeah.
5 point.
Oh yeah.
You got one, so it's an odd.
You'd have to set up an equation and your word problem and everything.
You gotta see his work.
Yeah, show work.
Who else needed that updated?
I do.
Even though now it's already out of.
Questions?
Alright guys, so any questions on what we went over last time?
5.1.
Yep.
Number 36.
That's one I have problems
Oh,
with
yeah.
as well.
Section 5.1, I fix it to until 1 to 6. Do I have an extra?
Negative exponents?
Say it.
You set it to 78.
Yes, exactly.
I did all one
Oh, you have more practice. No, you did it for your own good. Let's see now.
Did we cover negative exponents somewhere?
Here we go, here we go. Yeah, we did. This is section 5.1 number 36. And it just kind of looks ugly to begin with. Like that, right?
Yeah.
Now, look what you can do for yourself. What's the only operation up there? There's only one operation up there, really. Multiplication, right? I can multiply whatever order I want to. For example, what's a little side note? What's 2x times 3x squared? What's that? What's 2x times 3x squared? 6, because you did the numbers together.
X squared.
X
Third.
cubed. 1 more, 2 more, 3 all together, right? Alright. I'm going to do the same thing there. Why is it ugly? Because they're fractions and there's negative powers. Right? So what we did in our head here was we put the 2 and the 3 together and we put the x and the x squared together, didn't we? So what you want to do, if you want to do this, you could put the 1/7 times 7/8 times 8/9, put all that together.
Right. That's 56.
Because in our head we can do 2 times 3, but in our head we might have some trouble doing that. And then you can put the x's together. Now what happens here?
You have to find a common ground.
No.
You could cross off.
Oh, okay, that's right.
Right, so real quick word on that. The only time you need an LCD is the same time you need like terms.
So when you're adding or subtracting.
Adding or subtracting, right? Because I can't add x and x squared, but as we just saw, can you multiply x and x squared? Hell yes, even though they're not like terms. So like denominators are just like terms. And I only need them when I'm adding and subtracting. Here, what can I do with the 7s? And the 8s. So I'm left with 1.
I thought that was a 2. I thought that was 2 8s. That's what I was thinking.
No, you're fine. In that case, it's the same thing. It just wouldn't cancel. Plus, follow along in your book. Because my 7s look like other things. How many x's do I have left?
He's got 1 because zero.
Careful.
Zero.
I don't have any x's left, do I?
No, because
I have x to the 0.
1.
And 1/9 times, what's anything to the 0?
1.
Times 1, that's 1/9.
Yeah.
All of my x's cancel, right?
You were close.
How's that?
That's easy.
It is. I mean, allow it. Allow it to be easy. Guys, allow it to be easy. Another way to do this, the x's, what do these want to do? You don't have to do this.
Drop.
Yeah, so it'd have like,
X to the third. 1 over x.
is that cool? Because both of these want to go down.
Right.
And what is x cubed times x5?
X
So I have x to the 8th over x to the 8th, which is,
Oh,
I get the same damn thing, don't I? Of course I do. It has to be self-consistent or else we got to throw the whole damn thing out.
Wait a minute, where'd you get x to 8? Oh, okay.
3 of them, 5 of them, so 8 of them.
Okay.
Alright. So I agree with that one. That one looks ugly, but it's easy. Look at all those 7s want to go away and the 8s want to go away. That's nice. And then just add the powers on the x's. Yeah.
75, I don't know, it could be easy, but I just want to see why.
Oh yeah. I love these kind of problems. Which should tell you something.
Matt, you're a freaky guy.
Yes. That we know already.
If you say so.
Alright, now this kind of problem throws people off because they see the letter N and they get all freaked out. But the property does not care what the hell is up there. It doesn't matter. What do I always do when the bases are the same? What do I do with the powers when I multiply? Add them. Right? I don't care what they are. So what is up here? What's understood to be there?
1.
And what's 1 plus n minus 1?
That's something I kind of understood, but I wasn't sure. Okay.
Right? So for example, little side problem here. Jeff's part B. What's 7 to the m times 7 to the 2m minus 4?
7 power 3m minus 4.
Yeah, m plus 2m is 3m, and I got a minus 4. The property does not care what's up there. The property says if the bases are the same, you add the powers when you multiply. It doesn't care what's up there, right? Properties can't be based on what's in there. They have to be properties, period. So I always add when I multiply like bases. Now, the biggest mistake I see here, somebody would say 4. Somebody would say 49 here, right?
Yeah.
Let's look at an easier example. These are like variables up there. I want to look at an easier example for a second. What is 3 squared times 3 cubed? Now, if you say this, if you say 9 to the 5th,
3 to the 5.
that makes absolutely no sense. You're claiming that there are 5 9s, even though I just had 2 3s and 3 3s. So when I write this exponentially, have I done the multiplication yet?
No.
What does 3 squared mean? I have to multiply 3 times 3. I haven't done the multiplication yet. So if you do this, you're going against that idea. I don't have 5 9s. How many 3s do I have total to multiply? 5 3. So people look at that and they say 3 times 3 is 9. I know 3 times 3 is 9. That's because 3 to the 1 times 3 to the 1 is 3 squared, which is 9. Sure. Right? Do you guys see what I'm saying?
I'm just trying to do it different. If you have the 3 up there, then you said 2 plus, 3, or the exponent, that's the same thing as 3 times 3 with the exponent of 2 times 3 with the exponent of 3, right? You see what I'm trying to say?
No.
Okay, if you have 3 there, you write the 3 for the base, and up there you put 2 plus 3.
Oh, like that? Okay.
Yeah, that's what I'm saying.
Yeah. That's the same thing as this, yeah?
Okay.
Because when do I add exponents? When I multiply like bases, right? You can go both ways there.
Okay, that's what I'm trying to say.
I like it.
Why don't they
Okay.
just write it out like that to make it simple?
How do you mean this?
Yeah.
Because you got to know what to do when you have this. Because what you're learning right now is what to do later. And later on, you might have, guys, come here. What you might have later on is some function that deals with profit and revenue per widget, and you want to multiply it by how many widgets you're going to make. You got to know what to do with those powers. I mean, this is something for later. It's not always going to be known that you're going to have 2 and 3. If I'm going to write this, why don't I just write just tell me that, because you don't know. You got this piece from over there, you got this piece from over there, and you want to bring them together. You got to know the properties to bring them together. Right? So hell yeah, if they just wrote the answer, it'd be a lot easier, right? That's too bad for us. We got to know how to do it because it's not going to be written in a nicer way, right?
All it is telling us the basis stays the same, 3 stays the same.
Yeah. So hopefully you guys see why that doesn't make any sense if you put a 9 there.
No.
When I use exponents, I'm keeping track of how many multiplications I have to do eventually. I'm not multiplying anything yet.
Yeah.
So I got 2 3s to multiply, 3 3s, so of course I got 5 3s to multiply eventually. Yeah.
Sorry, I'm still confused about how x8 over x. I'm still confused about that.
Are you cool up to here?
I'm cool to there, yeah.
Alright, so I kind of skipped a little step, but what's this 1 over x to the...
Yeah, but aren't we looking for 1/9?
Well, the 1/9 is out here, I'm not worried about that. The 1/9 is what I got from this.
Okay, okay,
Yeah,
All right.
and the X's, I'm not looking for it, this is just what I was given.
okay,
So I gotta work with that.
okay, cool.
Okay.
3 to the exponent 5, shall we make it a 3 by 3 multiplied or not?
You could do that next. I'd rather see this at least. You could do the next step. Because if you just give me a number, you might have just plugged in your calculator. You don't understand the property, you just know what the calculator tells you.
But if we leave it like this, is it
That's
okay?
fine.
That's fine,
Yeah.
okay.
Now, on a test, I'll be careful. I'll say leave your answer in one form or another. But you know, if you get 3 squared, go ahead and make 9.
Yeah.
But if you get 3 to the 7th, maybe just leave it 3 to the 7th. I don't need that big ass number, right? Okay. All right, any other questions?
Number 72.
That's the one, let x equal -1?
Yeah.
Let's see, let's take this away. So for example, part A is x to the 14th over x to the 9th, and they say let x equal -1. Well, I would just go ahead and,
You multiply -1 14
well, yeah,
times,
I
right?
say, okay. -1 to the 14th over -1 to the 9th. What is -1 raised to an even power?
1 is a positive.
Positive, of course. Why? Because if I have an even number of negatives, there you go, Jeff. They're going to pair up and cancel, and there's nothing left. What's an odd number of negatives?
Still
Negatives, because they're going to have a pairs and a pairs. There's always going to be one left over, right?
Yeah,
It's gonna be -1.
So on the top I get +1. On the bottom I get, so overall I get -1.
yes.
So that's how you can attack each one of those. Just say, is it a positive, I mean, an even power or an odd power?
Okay.
So an even
Become
power
a
is going to make it a
positive or
positive number.
Yep.
So whenever they say let x be whatever number, it's a -1, you always put it in parentheses because it can make a
Yes.
difference, right?
Oh, hell yeah.
That's why I wasn't
If
sure.
I
if it
have,
was
if I have x to the 14th, I want to raise x to the 14th. If you make this,
it's a different
I'm
number, it's a
raising
-1.
1 to the 14th. Is x 1?
-1.
X is -1.
Oh.
So basically, whenever you substitute, you put in parentheses to preserve the operations. So there was a problem like that on a quiz a while back. It was like a squared, and a was -3 or something. So a lot of people did this. That's not right.
That's not right.
Did I square a? No, I squared part of a. I got to square a. Make it a +9, right? I got to square whatever the whole a is. I can't square a piece of it. So that's the general rule. When you substitute, put parentheses so you preserve what's going on. Yeah. All right. Cool. How we doing? Any other? Yeah. 39. Okay. Wow. Yeah, okay. All right, now this one, let me show you the biggest mistake people make. I'm gonna start working it out. Can somebody tell me what I've done wrong? Actually, before I start working it out, can somebody tell me what I should do first?
Exponents.
Take care
Definitely, can I do 2 times 3?
No.
Because then I'm going against order operations. I don't have a 2 here, do I? I have a 2. So actually, it just kind of told. The biggest mistake I see is this. Somebody writes 2, what's x squared cubed? X to the 6th, right? You multiply when you raise something with a power to a power, right? So I've already made a mistake, haven't I? Do you see the mistake I've made? The 2 can't escape. How did the 2 escape? Can't.
No.
Right? 2 cubed, x squared cubed, bam. Y -5th cubed is y to the -15, careful.
That's right.
You gotta multiply when you raise, yeah.
Times the whole other thing.
Yep. So now I've done that exponent. I gotta do that exponent.
So 3 to the -4.
I love it. 3 to the -4. X to the positive 16, negatives cancel. Y to the -8.
Why you don't divide it? Because it's the exponent.
Well,